This video is our third part in learning how to deal with the order of operations, and this video is mainly going to focus on equations or expressions that also include exponents. But before we deal with a problem that involves an exponent, we should probably go over what an exponent is and how we handle it. So let's take a look at an exponent. What we have right here is an example of an exponent. It is 2 raised to the fourth power, or 2 to the fourth power, however you want to say it. And the big number is our base, and the little number is our exponent. And all this is, or all exponents are basically, is repeated multiplication. Now what do I mean by that? Well, I want you to think about multiplication in general. Let me erase these. If I were to write, let's say, 2 times 3, a multiplication problem, well, this is just a shorter way to write 2 plus 2 plus 2. So we use multiplication to show repeated addition. Well, as I just said, exponents are repeated multiplication. So when I have 2 to the third power, our base, remember that's the big number, our base is the number that we are multiplying. And the exponent tells us how many of them we're going to have. So with 2 to the third power, we have 3 2's. And we're multiplying all 3 of them. So it would be 8. Now, since we've done this little review on exponents, let's try and solve an equation slash expression. It's going to be an expression because I don't have the equal sign on it. But let's solve an expression involving order of operations and exponents. So our expression this time is 7 plus 3 times 2 to the second power. If we think of our order of operations, we've got parentheses, exponents, multiplication or division from left to right, addition or subtraction from left to right. If we think of those, do we have any parentheses? No, no parentheses. So that one is out of the picture. Do we have any exponents this time? Yes, we do. We have 2 to the second power. So we're going to deal with that exponent first. And 2 to the second power is the same thing as, and I'm going to do it over the side here, 2 times 2. Because 2 is our base, it's the number we're multiplying, and the exponent says we're going to have 2 2's. So 2 to the second power is 4. So now we can rewrite what we haven't used yet, 7 plus 3 times 4. Now we don't have any more exponents, so I can cross that off. And then what would happen next? Well, any multiplication or division. That's our next step. So we would multiply 3 times 4, which is 12. Bring down what we haven't used yet. And our answer ends up being 19. So there we go. We've just solved an expression that also used an exponent. Let's try another one. For this example now, we have 4 plus parentheses 3 times 2 and parentheses plus 6 to the second power. Well, just like all of our other examples, look at our order of operations. Do we have any parentheses? Yes. So start by taking care of our parentheses. What is 3 times 2? It is 6. Now rewrite everything that we haven't used yet. And we do not have any more parentheses, so parentheses are done. Now look at our next step. Do we have any exponents? Yes, we do. We have 6 to the second power. Well, since 6 to the second power is equal to 6 times 6, we can say that 6 to the second power is actually 36. Now we can rewrite what we haven't used yet. and we end up with 4 plus 6 plus 36. Now at this point, we could just say, well, 4 plus 6 is 10, and then add in 36 as well. But since some of us might not need this final step, and it's just addition, you could just add it right across and come up with the answer of 46. So there is our second example where we had to deal with exponents. As long as we remember that in exponents, the base, which I've just circled here, the base is what we multiply by, and the exponent is how many of the bases we are working with, we should be fine. This next example might be a little tricky, so let's give it a look and see what we come up with. So here we have 4 times parentheses 3 plus 2 raised to the second power minus 15. Now take a real good look at our example here, and what do you notice? Think to yourself, is there anything that looks a little bit different or something you might be uncertain on? And it's probably going to be the fact that the exponent is next to a parentheses. All that means is, after we take care of what's inside the parentheses, we raise it to the second power. So let's follow our order of operations. We have parentheses, like we said, so we have 3 plus 2 first, which is 5. Now, as I'm rewriting everything I haven't used yet, 4 times 5, but it's not just 5. It's 5 to the second power, because this exponent of 2 has to go on our 5. So it's 4 times 5 to the second power minus 15. And our parentheses are done. Now we can take care of our exponent. 5 to the second power is the same thing as 5 times 5. So 5 to the second power is actually 25. Rewrite everything we haven't used yet. Now we are done with exponents, and we're at the multiplication or division stage. We have multiplication, so we can take care of that next. 4 times 25 is 100. Bring down our minus 15, and now we are at our last step, which is just going to be subtraction. And 100 minus 15 is 85. So even though we've introduced exponents into our expressions when working on order of operations, everything still works the same. We just have to know what these exponents actually mean. And all it means is you take your base, the big number, and that is the number you're multiplying by, and the little number, the exponent, is how many of them you are multiplying with. Hope you found this useful, and good luck solving your order of operations expressions.